So let me share my screen and presentation. So hello everyone. We met already yesterday, I guess, so we can avoid presentation again. What we are going to see today is a new pipeline that we want to add to the pipelines that were presented today. And this pipeline is specific actually for machine learning. And what we want to do is provide feedbacks as soon as possible to the data scientist, the ML engineer regarding their application. Because when you train the model, then you need to basically move it to production at some point, and the deployment might behave differently of when you created that model. So we want to provide this feedback as soon as possible. Also, another use case might be that you have different type of deployments that you can get. Imagine you have the Flask application, or TensorRT, or Seldon, or KF serving, and you want to know which is actually the best solution for my application. So this kind of pipeline in the future will be able to deploy to have different kind of deployments and provide all these metrics back, so the data scientist and the ML engineer can have a look at the performances, at all the metrics that are available there. But we will see in a moment. So yesterday I already started to present this schema. So here you have all the technologies that we have at the moment. So we have ODH on OpenShift, you have Jupyter Hub, you can spawn different images, you have Elira, you can create pipelines, you can do your training, and everything at the end, we want to put it in a place where it is called the source of truth for the project that you're doing. In this case, we consider the project on GitHub, but in the future might be also S3 or other kind of sources for data sets and models in general. So then we basically had a look at all the automation and services that you can use. So basically to avoid and to reduce most of this mundane work that you don't have to do, so you can focus on your application. And this is something that the pipelines can do, because they can basically create images for you, they can make release for you. And then you have also the bots. So if you think about the dependencies of your application, also this need to be maintained. And you have something that is automated, and it's like a new colleague for you that is taking care of that. So you don't need to focus on that. You can focus on your application. And then we also talk about the continuous deployment and monitoring, and the deployment can be done with Argo CD, for example, or GitOps in case of OpenShift products. So in this way, you have these tools, and all of this is basically to boost your productivity, to reduce all this kind of work that can be done by automation. So you can really focus on your application. So this basically is what the typical workflow that you have. So you work on your ML model and deployment and development of your application. You create pipelines for continuous training. So if there is, for example, data drift, you want to retrain your model. So all these pipelines can be triggered automatically and based on events. For example, if you use Kafka or similar technologies, and in this way all this can be automated. So at the end, what you really need to focus in is to make sure that your model is always behaving correctly, and the rest is kind of automated, and monitoring is going to help you for that. And also this part is also automated. So as you see, most of the things can be automated for the user, and in this way they can focus really on their problem. So this is just another perspective. I think you saw it in other slides as well. So all this process in the MLOps is that you are continuously creating models during to the pipeline for training. So this is something that happens because there is data drift, because there is new data to consider, or maybe there is a new dependency in your software stack, or there is a CVE. So in this case, also the image needs to be recreated. You need to retest and obtain the metric to be sure that the model is still behaving correctly. Then you need to have the image, and then this image can be also basically redeployed by Argo CD. So in that case, the system will will automatically redeploy everything. But all this process is something that can happen in different situations. So either there is a new model that has been trained, or there is a new dependency, or new data have been provided, so the model needs to be retrained. So all these cases might generate new changes in your project. And typically, if you are basically using GitHub as your source of your project, you're going to open a pull request. Either you or a bot or someone is going to open a pull request to make these changes. So there is a new model version, there is a new data set, there is a new software stack. So all these changes basically will change something in your application. And what we want to do is to provide feedback about all these changes. So if the bot open a pull request saying that there is a new software stack because maybe there is a CVE and you need to change that version, then maybe the performance of your application are changing. Or maybe the model is a new model and you want to know how this new trained model is going to behave in production or in the deployment. So what we want to do is to have a new pipeline, and this new pipeline basically is going to be added to the pipelines in the ICOE that Arshad presented. And what we want to do with this pipeline is basically providing feedbacks on this problem. So why we want to provide this feedback? As you saw, all of this process is not static. So the development of an application is always dynamic, and especially today with all the new applications and all the new packages that comes, all new data, new models. So you want to improve your models a long time. You don't want to keep them always the same. So everything is completely dynamic, and we need to have a way to basically boost our productivity. So we want to speed up the process. So instead of waiting waiting and verify what is happening once the model is deployed, you can immediately see that while you are working on your development project. So you see in GitHub, when you open a pull request, you can immediately see these are the metrics for the model that you wanted to see. The metrics, this is the test that was used, this is the data set that was used, and at the end you're going to see the metrics. So in this way, the user can really focus on the modeling and on the problem itself. And this also reduces cost, of course, because the time that you need to spend to do this work can be basically used for other things. And in this way, this automation can help there. What kind of feedback? The feedback might be of different level. So you have the model metrics. You want to know the performances. Basically, you have a model, an application with the model deployed somewhere. You want to run requests out of the endpoint that is giving prediction, and you want to make sure that this test data that you're using are going to give you the good performance that you're looking for. So the performance is still at a certain threshold. The latency is still at a certain threshold. So if you look at the application metrics, but you also want to see maybe how the platform is behaving. So the application has enough resources or is using too much resources, then something else needs to happen. And this also can trigger other things like, I don't know, automation you need more resources. This is something that can be automated for your application, maybe with the AIOps, for example. But all this information are useful and can be immediately seen by the data scientist or the ML engineer, and they can take action on that. So this is something that I already mentioned. There are different personas that might benefit from it. There are some metrics that comes from the operational side, but also for the deployment of the application. So memory consumption, CPU usage, latency, and also the data scientist interested in the model performance in production, because they want to make sure that whatever performance they were expecting from the training then is still available in the production. When we want to give this feedback, as soon as possible. So when you're developing, and this is done usually with GitHub, then when you open a pull request or for any kind of change, so either is a bot or a human doing that, then you want to see immediately what is happening and take action on it. So if the model is better, then maybe you want to approve that pull request. You can create a release and Argo CD will make the deployment. So all the machinery and all the automation that is present is still there, but in this way you can basically take decision immediately, not waiting for the what will happen later. This can happen also for, as we said, for a new model. So there is data drift. There are new data to be used for your model, and you train the model again. There is a new version. Then you want to see, is this going to behave better or worse? And is still this type of deployment the best, or you need another type of deployment? Maybe at some point there is a limit where now I need to use GPU. So these kind of things can be basically obtained in advance. And also when there is a data set, this is another example. Deployments. As we said, there are different type of deployments. There are different type of hardware where you can deploy. There are different kind of technologies to deploy. There's KF serving, Seldon. If you have GPU, you have TensorRT. You can have also simple Flask application, maybe for first prototypes. And also there are other type of deployments or optimized deployments that can be done. So this is just a simple list, but this list can be extended. For the purpose of this proof of concept, we have a Flask application, but we want to extend it, and we want to actually get feedback on this and eventually provide more features to that. So what do you need to use this pipeline? Well, you need basically the requirements for the ICO ECI. So there is the ICOE YAML file, which is present on your project. You need a model to be deployed, and then you need a test. So this test can be something that can be created together, maybe by the data scientist and the ML engineer. So they want to know some specific metrics for certain things. Some would be default, like the memory consumption and the CPU usage, but also you want to know maybe some specific performance metric on your model, which are not always the same. If you're doing some type of machine learning or another, there are different kind of metrics that you're interested in. So this is the knowledge coming from the data scientist. The operational side will come from the ML engineer. So let's have a look at one example that we created. So as I said, we will use the Flask application. In the project that we are considering, which is actually the same tutorial that we presented the other day, you have the ICOE YAML file. So in the ICOE YAML file, you can always state if you want to build an image for your project, or also if you want a deployment of that image. And at the moment, what we check if there is this kind of keys in the ICOE YAML file. So we know that there is a deployment that can be done. And in that case, we use the same inputs. The pipeline reuse many of the tasks that are available in the ICCI and add some new tasks specific to this purpose that we want. Regarding the test, so as I said, this is one way to do it. We are using Behave. So Behave is one library in Python that allows you to use the Gherkin language, and you can use the natural language to state what is your test that you want to do. So this is, you have feature and scenario, and you want to have a data set that is going to be used for the test. You want to have a deployment that is going to be created by the pipeline and deployed by the pipeline. And then you want to run basically against the endpoint this kind of inputs data and gather metrics out of it. So at the end, we have this new report that shows all the metrics. This is just a little schema regarding the different steps, but I think we can have a look directly on Tekton because that is something that I already started running. Let's see the status of the pipeline. Otherwise, we can retrigger it. And I will show you also, I will describe the steps while they go ahead. So the pipeline itself, initially we'll check, of course, if there are all the inputs required. So if you have a test that you want that needs to be run, if you have a model that needs to be used, and if there is an image to be deployed. And if not, they will simply stop there. Then it will configure the pipeline. So there are all the inputs coming from the ICOE YAML file, but also some default one because, for example, the pipeline by default, we use a certain namespace. you can also customize this to use maybe the user namespace. They don't want to run this in some specific namespace accessible to everyone, but maybe they want to have this deployment in their own namespace. So this is something that you want to customize. The type of test can be also customized. The behave one is something that we already considered. The next step is actually doing the build of the image from your project, and then it's going to push to the registry related to this. This might take some time, so maybe meanwhile I can go ahead with the schema that I was going to show you. So at this moment we are here. So that basically the pipeline is going to build and create the image that needs to be deployed. Once that is done, it's going to deploy the image in the namespace that is the one that is selected. In this case, we're using the default. So it's going to use the AIC ECI, or actually it's the operate first namespace, because this is already present in the operate first. Once the model is deployed, then we are going to discover the route. So for the deployment, we are using at the moment customized objects from Kubernetes. So we use and OpenShift actually, the deployment config, the route, and the service. This is something that is created dynamically, and we add the image in it. So then we can also control, actually when everything is done, we can delete everything using the selectors in the objects. So once the model is deployed, then we are going to discover this route. And then what will happen is that it's going to install the test. So the test itself will have its own dependencies probably. By default, can check if these dependencies are present in your project, or you have some specific overlay that can be used for the test. And once this is ready, then it's going to gather the metrics. So if we see, it's still running this task, but for example, here you can see that it's using some specific overlay, which is in this case the inference one, because we want the one that is going to be used actually in the deployment. And at the end, when the metrics will be gathered, the last step will be just to comment in the PR, and the metrics will be also stored on Zeph. So in this way, we can always have a look at the metrics that are available, and you can compare across the different tag that you created, across the different pull requests, or across the different deployments that are available for the single task. So it will take some time, probably, maybe for some resources, but at the end, I already ran it a few times just to make sure that works. You will get something like this. So the report will basically show you the test inputs and everything that was used, the namespace where this was run, and then you have some metrics. So these metrics are something that were created for now by default. So you have the latency. You run a certain number of requests. I reduced the number for now because for the purpose of the demo. You can see also the model version. In this case, is coming from this PR, because this PR is basically the version of that is created on Quay. And then you have also platform metrics. So you can basically have a look at the pod and see the CPU usage in that time frame, and also the memory usage on that time frame. So in this way, you have all these metrics that can be used to make decision out of it. So at the end, you will have a comparison maybe of different type of deployments. You can compare the different tags. So this is the idea that we want to provide. And I think that's all related to this. It will still take some time, but you can ask question meanwhile, and please ask question or give us feedback around this. Thank you.
Francesco, I think you said it a few times. We are going to use an overlay to build this or that. Did you go into what an overlay is on one of the last calls?
Quickly, but maybe I can go through it one moment. So I think I explained it during the tutorial, but let's go again here. So overlays, well, it's a concept, if I'm not wrong, that comes also from Argo CD or other technologies. Basically, you have some common manifest, for example, and you want to deploy to two different clusters that have some specific requirements. Then you can have the basic, basically structure, and then you can customize the different cases. So these overlays basically have different features specific for the environment that you want. And this is something that we are also using for the dependencies. So if you imagine that you have different steps in your pipeline, then one step might be download the dataset, which is something that maybe requires only some or I don't know, request or some simple package. So that is a very small dependency that you need, and that can be an image just for that task. Then you have inference, actually training one. In that case, in the training, maybe you want TensorFlow and you want GPU. So you need to have a specific image for that. So this is something that Tot can do, and together with the ICOE pipelines. So it knows what kind of a stack you want for this specific environment, and maybe you want GPU. So this is something that can be done. Here you basically have software stacks for the different overlays. So each of them are different and are specific for the task and the purpose that you want. And this is something that you use together with actually the AICOE YAML file and the TOT YAML file. So the AICOE YAML file has a similar structure. So it will create different images for the different overlay, or if you imagine this different task that you want in the pipeline. And TOT itself will also do the same. So TOT also knows that you want latest recommendation, so latest stack for that specific environment. For the training, you're interested in performance, and maybe you want also to use GPU. So you want to have this kind of choices when you want to work with this environment, because there are many combinations that can come. So this is basically a flexible and easy way to help the user to work on this. And yes, that's all I think. Does that answer the question, Christoph?
Yeah, kind of. Because my question was, did you talk about it? And now you talked about it. So thanks for that.
Yeah, because I don't remember if I talked about it enough or someone else talked about it.
I mean, it's in general, it's a good concept, right?
Yes.
Whenever you see something like an overlay, it is trying to isolate and to specify in more detail an environment or something, yes. Right? People will see it all over the place, I guess, in Argo CD, as you said, or in the TOF pipelines.
Yes. There are other questions. The pipeline is now deployed everything on the cluster.
Francesco, a quick question. So in the YAML file that you just showed, I saw that you were mentioning about the recommendation type. Maybe I missed that, but can you just elaborate a little bit? Like, what are those different recommendation types and how they sort of relate to how you configure it?
Yes. So, I mean, the purpose of TOT as a recommender system is not just to resolve your stacks, but to give you the possibility to choose, to make a decision out of the stack. So I don't just install TensorFlow because I need it. I install TensorFlow because maybe I want the latest, yes, because it's something that comes from, for example, PPM and all the other dependency managers. But maybe you are interested in a specific, and if you saw the talk from Frido before, you see that there are different layers, and all the different layers needs to work together to give you certain environment and certain capabilities for your application. So TOT is able to basically move in the space of the dependency tree and select what is the best in terms of the decision that you want to make. So if you're interested in performance, TOT as observation that comes from micro benchmark and test for a specific application. So you gather performances out of it. So we know that if there are two different TensorFlow version or two different TensorFlow version from, or the same TensorFlow version, but for two different index, then thoughts as observation related to which one is better in terms of performance. So this kind of decision cannot be made with simple resolvers. So thought to give you basically another layer of decision on what to have to do. And the same is for security. So security takes into account maybe performance as security, something that is actually could be that is the opposite in some cases. So you have one very performant package, but maybe it's not that secure, or the opposite. You want a very secure package, but the performance might be different. So this kind of decision can be made by thought. You don't have to worry about it. What you have to worry is what is the application I want to do? What is the task I have to work on? I'm interested in training, so for sure I want performance. And thought can give you basically the best software stack for it. And this is some of the recommendation. If we go in TopStation Ninja, if I'm not mistaken, there is the link to the recommendation. Let's see if I am able to find them, or maybe the link, or Frido or Christoph are gonna send them. But no, yeah. So
Frido was faster.
Yes. So we have different type of recommendation, and as Frido explained before, this is something that no other can do. So you cannot choose performance for when you run PPEM or the others. So thought basically give you another layer for it. That something that you can use to make decision when you want to build some specific application.
I think this perfectly fits into that overlay concept, right?
Yes.
If you're running Python 3.9, which is the most current version, and you're going to resolve your software stack, there might be certain packages, and I freaking can't remember which one we had as an example, which simply do not work with Python 3.9. So what you're going to do now, you depend on features of Python 3.9 because you want to use the latest and greatest whatever package. But at the same time, there's a different package which is not compatible with Python 3.9. That is something that we can advise you in and give you guidance on, but that's not really a solution. If we simply say, well, they're mutually exclusive, these two packages, and the solution out of that situation, or how to escape out of that situation, is to introduce overlays. Right, so you have one notebook which really depends on 3.9 and all the packages work with 3.9. That is one overlay that might be used for, I don't know what, data cleansing. And the other overlay is for Python 3.8 with all the old stuff that requires Python 3.8. And that goes into the, well, you name it, training overlay, right? So you really have that combination of, we have a lot of knowledge and we can guide you and advise you on how you should build your software stack. And we have all the tooling to separate these software stacks from each other. And we have all the tooling to put it into a container image and deploy it. So that's the very large view here now.
Awesome. Thanks, Francesco. Thank you, Christoph. Does anyone have any other questions?
Oh, yeah, maybe just a comment. We're waiting for about 8 or 10 minutes now for the pipeline to finish. That might feel like, oh, damn, it's never going to finish, especially if you're in a tutorial or demo situation like this. It looks like it's a lot of time. But keep in mind what's happening in the background. There's a full-blown application being deployed and metriced, if that is an English word. So we derive all the metrics that we need from the platform, the OpenShift platform, from the application itself. We're going to store them back into GitHub, and building container images takes a little bit of time. So if you relate that to your data science work or to your DevOps work, it is not really a lot of time. I mean, if you get informed upfront that something will not work in production, and that information takes 10 minutes to bubble up to you, that is good 10 minutes to spend. I don't know. what the 9-gag equivalent is, like debugging 15 hours saves me 5 minutes of waiting for CI/CD or something like that, right?
I guess in any case, CI is quite longer. Some of the CI for some projects are very, very long. So
yeah,
10 minutes is okay.
All right. Thank you, Francesco, again for presenting. If you
Thank you
guys
for
have
having me.
any more questions, feel free to reach out to us. I think now you're all familiar with where you can find us. We have Slack as well as Google Chat, so reach out to any of those platforms. And with that, we will be concluding the bootcamp. I hope you guys found it informative. We have all the sessions recorded and uploaded onto the source page. If you don't know where to find it, please reach out to me. And with that, I wish you all a good internship here in our team as well as at Red Hat. And feel free to reach out if you have any more questions. Thanks, folks.
Thank you, Ima.
Yeah, thanks, Schema. You set all the stuff up.